Welcome to the lecture Game Design and Game Development. In this lecture, we will get to know the topic of usability engineering, which is very important for successful project development. To make it easier to find the relevant information later, we see the list of content here. Let's start with the question, what do we actually mean by usability engineering? Usability engineering is a critical discipline within the field of software and product design that focuses on enhancing user experience by ensuring that products are easy to use, efficient, and satisfying. Our usability engineering framework has usability engineering at its core. We investigate and understand existing principles, apply useful methodologies, look for best practice solutions, and always have a user-centered design. We can say that usability engineering represents pure user-centered project development. When we look at usability engineering, we will quickly realize that a number of different related disciplines come together here. The most important of these are certainly design, media psychology, human-computer interaction, artificial intelligence, mathematics, software engineering, complexity, interaction design, cognitive science, and user experience. We want to place usability engineering at the center of our considerations now and take a look at how this term, from my perspective, can be easily understood. First, we design something. When we're at the beginning of a project, it can be something very quick and very simple. With this design, we want to express questions. We aim to prototype this design along with these questions, with the least effort. We call this implementation. It can be very abstract at the beginning and later become much more concrete. After that, we want to evaluate the whole thing. This way, we have answers to our initial questions. Now we can incorporate these answers into our design process and move one step further in the project. This cycle significantly guides the project development. With this approach, we have presented the core of usability engineering and are hopefully able to not only successfully carry out projects, but also keep the target audience in mind. In the end, we have created something that will be accepted by the target audience. We must be aware that poor design only costs time, nerves, and money. You surely come up with many examples from your daily life that somehow annoy you. You may ask yourself, why does it have to be like this? Why can't it be better? Now, of course, the question arises, what strategies are there to design products successfully or to successfully complete projects? I would like to emphasize a very important point in this lecture. In software engineering, we often talk about the so-called application-oriented software development process. At the end of the day, the focus of every software is the human being, whether as a pure user or as a developer who uses the software as part of a larger concept. We should stop and put people at the forefront. I advocate more for the so-called user-oriented software development process. This is also what usability engineering is all about. To develop software for people, we need to understand their tasks, goals, and values. Ideally, we should cleverly involve users from the very beginning and throughout the entire development process. We ourselves need to become familiar with the work and the specific environmental situation of the users. Later, we will talk about self-referential design, which we need to overcome. It's not easy for everyone. We simply need to consider the abilities and the situation of the people and, if necessary, consult experts. You surely remember these images from a previous lecture. You remember what I said about them? Now we have the opportunity to take the right path. Now let's take a look at the power of prototyping. A famous example that is often cited when talking about prototyping is this one. It shows a functional prototype of Kodak's first digital camera. There was no comparable device yet, and the question was what control and application elements such a digital camera should have. The result was this prototype, which already included almost all the elements we know today. The prototype was connected to a PC in order to simulate the elements accordingly. Prototyping is an efficient strategy for dealing with things that are difficult to predict. This is what the game design and game development course is all about. We try to develop projects that are innovative, interactive, and intuitive. Innovative means that we want to develop something that doesn't exist yet, so we don't even know whether it will be well received and used by the target group or whether it will fail. This corresponds to the highest degree of creativity and requires a high degree of usability engineering. This brings us to the topic of complexity. When we take a look at the complexity in the game of Go and see the technical strategies that exist there, we may be able to derive how we can navigate through our complex design world in the software development process. Go is a game with very few rules and uses only one type of black and white game pieces. However, it takes an incredibly long time, many years, to slowly understand the complexity and find paths that ultimately lead to success. Here we see a complexity analysis of various well-known games in terms of the number of game positions on the left and the number of possible game sequences on the right. For example, we see the game of chess here, where 10 to the power of 123 possible game sequences exist. In comparison, the estimated number of atoms in the universe is approximately 10 to the power of 78. This means that there are significantly fewer atoms in the universe than possible game sequences in chess. When we look at Go now, its complexity surpasses chess by several categories. Now, of course, the question arises, how can computer programs, and I'll take the time before AlphaGo and before deep learning, actually play games like Go and make meaningful computer moves? A widely used strategy is called the Monte Carlo method. We see a concrete world of game situations on the far left, which we have already worked on, and now we wonder which path is the best one. In AI for computer games, we always assume that the opponent also wants to play the best move, and we want to adapt and respond sensibly. For example, we see a leaf node with values of 3 and 3. This means that up to this point, 3 games have been tried in which the player with the black stones has won 3 times. This is the best variant so far and is called the main variant. Now we want to expand this node. The idea is to play a lot of random games starting from this node and see how they turn out. Statistically, this is a good strategy. Afterward, we incorporate the new node into the tree and update our knowledge about the path in the entire tree up to the root. We use backpropagation for this. Now another node might turn out to be the best leaf node, and we continue working there. Some of you might already be familiar with this, but there are, of course, great techniques to explore the search space more efficiently. I just want to briefly mention iterative deepening and hash maps here. This means that if we want to handle a high level of complexity, we need to focus on goals. These goals provide us with a natural evolution of the design. From left to right, we see the progression of time in the project. At the beginning, we have a lot of possibilities, and we slowly move towards the goal. Along the way, we still allow for larger changes to alternative paths. However, the further we progress in the project, meaning over time, the smaller the allowed changes should become. In the end, we might even get to things like colors or fonts on the agenda. In the end, we will no longer allow changes to the concept. Let's take a look at perhaps the most famous example of prototyping there is. Here, on the left side, we see a piece of wood. Yes, a piece of wood. And this represents the first prototype of the PalmPilot by Jeff Hawkins. He carried this piece of wood in his breast pocket and had it with him at all times, in every meeting, in the elevator, during conversations with colleagues. Whenever the opportunity arose, he thought about the situations in which he could use his device and how. He even had a stylus with him and considered what functionality and added value he could incorporate into this device. That's truly an inspiring story. Try to keep that in mind when it comes to prototype development. It's important to remember that prototypes have rights too. So, for instance, if someone says about your project isn't complete because the prototype isn't fully developed, you can argue, hold on, maybe we should discuss what a prototype is. Because a prototype focuses on the essentials and doesn't need to be complete. For instance, there are prototypes that focus on the feeling. They seek answers to questions like, how should it look or feel? Or there are prototypes that focus on functionality. Here we ask, how should it work or operate? There are also prototypes that concentrate on a role. In such cases, we might ask, what is expected, or what will the user experience be like? So we must always remain flexible to allow for easy and quick changes. Otherwise, we don't even need these prototypes. This brings us to an important rule in the context of prototypes. Don't invest so much time in things you may discard. It's clear that if we want to be flexible, we must be able to separate from a part or even the whole. Hence the addition of this important third point here. Let's move on to another important point. Prototyping can take place on a small scale as well as on a large scale. Let's take a look at the example of Boeing here. The designer Walter Darwin Teague, for instance, placed the first prototype in department stores and invited customers to take a seat. He wanted to observe people and, in this way, gathered a lot of valuable insights that he could incorporate into further design concepts. Nobel Prize winner Linus Pauling has a very useful quote for us in the context of prototyping. The best way to have a good idea is to have lots of ideas. Here we see the mouse from Microsoft as an example. Before the one legendary variant with the Windows PC then really went on sale, over 200 test variants were created and tried out over a long period of time with test users with left and right-handers. How should we proceed the development of ideas and prototypes? For this purpose, let us once again draw a suitable analogy from the field of natural sciences. Simulated annealing is about solving complex problems, and not just with a good solution, but with the best solution. The whole idea, expressed in a formula, shows that we trust a value with a certain probability depending on a temperature. For example, if we are looking for a minimum in a solution set, we do not always go straight down, but also allow it to go up. At the beginning, going up and down is about equally likely. Over time, the temperature decreases and we trust the values more and more. In this way, we can find the global minimum. We see in this animation that we can also pursue the goal of finding a global maximum. This strategy can be used, for example, in the 8 queens problem, where the aim is to place 8 queens on a chessboard in such a way that they cannot capture each other. The method is also used, for example, when folding proteins. We see here in this nice animation how the program parameter set representing a solution are plotted as a point moving in the solution space. Over time, jumps upwards become less and less likely, and thus we move into a global minimum. What can we take from this optimization strategy for our rapid prototyping? Well, we don't want to minimize errors here, but maximize the quality of the result. This is just an interpretation of the result, so we are looking for the global maximum. At the beginning of the development process, large jumps are still allowed, meaning changes in the concept. Of course, we must always try to evaluate the results, otherwise the corresponding feedback is missing here. So in the beginning, the concepts can possibly worsen a little bit. In the course of time, less and less changes in the concept are then possible, and thus we converge step by step, hopefully, to a particularly high quality result in our project. We want to allow alternatives in the concept and in the project parts. This raises the question of when we want to allow what kind of changes. We have to be aware that costs are incurred during product development, and this is a decisive parameter in the industry. We have to ask ourselves, what dependencies arise from the product, or how will customers react to changes? It is clear that when we release physical products to customers, costs rise very quickly and in a very short space of time because things have already been produced. In the case of delivered software, we can perhaps help ourselves by sending an update afterwards, but here too, customers will not be happy to work with faulty programs. Things may have to be recreated. When we offer software as a service, we have longer periods of time available. Ideally, the customer will not notice any changes. So we hold the biggest changes as soon as possible. We summarize, prototypes are questions. A famous quote from a children's program says, "Those who don't ask questions remain stupid." Therefore, We draw the consequence and ask as much as we can. Now another very difficult question arises: how can we make success measurable? How can our prototypes be evaluated? In order to find an answer to this difficult question, I would like to take this opportunity to ask a few more questions that might help us. After all, we are talking about usability engineering here. Why evaluate design with people? Why learn how people operate interactive systems and use them for themselves? What things do we want to learn about an interface? How can the design be compared to another? Can people figure out how to use the system? If we change the interface, how does user behavior change? How do things change over time? We have now heard many questions to help us evaluate a system with the user. It's all about the user around the target group. This is what we understand by the user-oriented development process. After listening carefully to this lecture, answering the following comprehension question should help you to summarize the most important statements again on your own.